Today we are going to discuss the MIPS assembly. We will continue our discussion on this MIPS language. So last time, let me review a little bit. Last time, actually, we talked about the instruction type, okay? In the MIPS processor, we have this different instruction type. And this instruction type actually operate on the processor of the MIPS. Let me bring up the slides for the MIPS processor, the data pass. Okay, so on the machine, actually, we know MIPS processor is like this, right? That's your control unit and your data pass, ALU and register file. And then we talk about this different register file. And we also, last time we talked about the memory mode. This one's called memory address mode. And MIPS processor's memory access mode is simpler. And last time we talked about, in general, the access mode has so many different kinds. So what is the instruction related to memory access mode? That is, when we talk about a processor, we basically have a data pass. We have some ALU unit. We have some latch. And then we have some I/O interface, and go back to register file. And there is a control unit, right? And then this is inside a CPU. Okay, and then there is a memory. So from memory, each time we have a program counter, we count it and then get a instruction, get that instruction and put into an instruction buffer. The instruction buffer got decoded to control the control unit and then send out a control signal to control the different data there. So there is a register to register operator, or register with memory, then you will load some data from there to the register, or you will load the data to the operand. Okay, or sometimes you have the register to immediate data that you put a 3 in there to do operation right away. So this different kind of the operands in your instruction is called address mode. So there are several different address modes. And then different address mode will actually end up with different instruction format. Okay, what is instruction format? The instruction format is the R-type instruction, the J-type instruction, and I-type instruction that we see. So each one of these, now this one is immediate access instruction format. Okay, this one is direct addressing instruction format that you have opcode and address. And then this one is indirect addressing, so you have opcode address and use that address as a pointer. And you can also have this one that is actually operating with register number, register address, and use register as a pointer. So, and this one is the displacement accessing. You have register and use that register number as a pointer with some offset address in the instruction. So all the instruction will have different format according to your address mode. So you end up with several different address mode. And those different address mode will come out with different addressing to access different register or access different memory location. And then for your ALU, you will get the data from different locations. And then you end up with different instruction set format. So each instruction has different addressing mode for different language. PTT-A, PTT-10, PTT-11. Each one has different format for the instruction. And microVAX instruction, Pentium instruction for Intel instruction. So each language has different instruction set and has different memory address mode. So we end up with this one. And in our MIPS processor, we have the R-type, register to register type, immediate type, and the jump type. Okay, 3 different types. And then last time we actually finished up to the different system call and template. And then now, actually we also finished this one directive. each derivative, I'm sorry, not up to here. Okay. So what we end up with, last time we talked about a template, the system code, 10, 12 different system code. And then we have the memory derivative, this different derivative, we finished that. And then we talk about the use of, basic use of the MIPS register file. And we done this, right? This running QtSpim, we finished, right? And then now, today we are going to start with this pseudo instruction. Okay, so we talked about some instruction and data paths. And today we are going to start this one called pseudo instruction. So what is pseudo instruction? Pseudo instruction is like, I normally write instruction for machine code, for my assembly of machine code. So each one actually some sort of a code. It already mapped into 1010 machine code, right? That's normal instruction. But here, actually, it is also possible that you actually, in front of this instruction, you can write your own pseudo instruction, and the pseudo instruction can be directly translated by your assembler, so that you transform to real instruction, and real instruction write to machine code by assembler, by assembly function. So pseudo instruction are not real instruction, but it actually can have one-to-one mapping to real instruction. So it just works like normal instruction. So pseudo instruction does not correspond to real MIPS instruction. Instead, the assembler will translate to pseudo instruction. So it's somewhat like the subroutine code or macro code. So for example, the end result, you will have real machine code related MIPS instruction. Eventually, you will have this, but you can actually group some of the instruction into some pseudo instruction. So every time you write the pseudo instruction, and it will be expanded to the real instruction. So that makes things easier to program. So pseudo instruction not only make it easier to program, it also add the clarity to the program. So it's easier for you to read. So we can write a pseudo instruction on QtSpim, so that the QtSpim may be a smaller program, .s file, and then it actually loaded to QtSpim and expand. Some pseudo instruction go into a bigger instruction, listing of instruction. Some part of it may be expanded, right? And then this one is real, and then you do one-to-one translation to machine code. But when you write a pseudo instruction format and real instruction format on the left. So you can save time and make it more clear. So what are the pseudo instructions? For example, like this one, move T0, T1 is copy the content from register 1, T1 to T0. Okay, so the source would be T1, destination is T0. So you move there, but in fact, this one is not a real instruction. It actually uses the add function to complete that. We'll show you what it will be used. Okay, like this one, load the immediate data. So you load some immediate data as 3 or 15 into a register. So that actually load the 32-bit or 32-bit or 16-bit for that. Or load the address to a register. Or load a word to a register. That's 32-bit over here. And you also have a save a word into a register. But these are not instructions. They will be translated to the machine code in different ways. So for example, like this one, move T0 to from S0 to T0. So basically you actually add S0 and 0 and then saving the result to T0. So because S0's result will be add up with T0, and the end result after the adding, it was set to T0. So effectively this one, because the 0 doesn't take effect. So effectively it's just like moving the S0 to T0. Is that okay, Eric?
Yes.
So add the immediate, like I add the immediate the value of 0, and that immediate value of 0 actually had nothing. So actually, I do this. I actually do 0 plus my S1's S0's value, and then save that to my T0. But effectively, you are getting data from S0. S0 actually had no effect, and then S0 directly saved to T0, and that finished the function called move. So you will move from source to destination. Move from your S0 to your destination T0. Okay. So this one load small is an address, right? And then into a address. That's just like adding a small with 0, and 0 register actually always save as 0. So actually, it's the data of the small will be moved to S0. So actually, S0, S small is a memory location. So now it's not register to register movement. It actually is loading movement from the small variable. So actually, in the memory, you have a label for small. And then I load this one to the adder. And then my 0, that's S0, the register 0, sum up together and then save to RS. So RS will save the data from actually from small, because 0 take no effect. So actually it's just like loading the data from small to RS. RS is a register. So that's actually loading small. So and then this one actually load the immediate data peak. Okay, so this one actually, this one is loading unsigned the immediate upper intermediate data. So actually from the peak actually is 32-bit, and then the upper, you will load the upper one into your memory. And you can also load the lower part of the peak and then move to the other instruction using the ORI instruction. So upper of the peak and lower of the peak is not real instruction. If you were to do the translation, you will have to break it yourself, figure out what's the quantity. Okay, so basically upper and lower of the data, you actually just like you're loading the number peak to the register, or you loading the peak as the address to the RS register. Okay, and you will be translated to these two instructions, loading upper immediate data. Okay, something like that. Is that okay so far? So the left hand side is not real instruction; it's a pseudo instruction. It's a instruction. Right hand side is the real instruction. So as you look through the branch instruction, branch when equal or branch not equal. Okay, this one is called branch equal. Branch equal. Okay. Okay, this one actually comparing the result of the two registers. So it is actually effectively equals like if S10 register equals S11 register, then we do branch, we jump to somewhere else. You know, when two are equal, we do something like that. And you also the branch greater than, branch less than. So before we actually compare the data, you have to prepare your register to be compared so that we know that whether it's actually equal or not equal. So basically this instruction branch equal, say target register 1 and target register 2, you have to trace back where does the data from, say A plus B, C plus D. Then you are trying to compare if A plus B equals C plus D. So before you actually do the comparison, you need to make sure that your T1 and T2 register are prepared, loaded with the right comparing operands or expression that you want to have. So you have branch equal, branch not equal, branch equal, greater equal, branch greater than, branch less equal, and the branch less than. Okay, these are different branch functions. Now, so here actually on the left hand side is a pseudo instruction. Say if these two are equal, I'll branch to the location here, right? I'll jump to the location. So actually right here, I'm trying to compare the 0 and the AT value, and this one is subtract. So subtract. So we actually have the T0 minus S0 result stored at AT, right? And then we compare if the AT equals 0, then we go to label. So basically, this is the real instruction we will use. But the pseudo instruction is on the left-hand side. We try to compare the two register value. And then if two are equal, we will jump to label. But in fact, the operation in the processor is not like that. You need to do subtract the two register on the left, on the right. If the two the value on the right subtract, the result will be stored in at the AT. Okay, and then the AT value will be compared to 0, and the register 0 is always stored with 0. So then you will be able to compare and jump to label. Okay, greater than the same thing, you actually use that. Greater than, you can use the not equal one. Less than, something like that. Okay, so these actually are some labels that you can use. I mean the label and the pseudo instruction. So here, this one I have to check. Okay, this one I have to check. Maybe there's some different instruction can be used. Okay, I'm not sure here is 100% correct. But conceptually, you can actually do that. And then system call. System call, because you are calling to print out integer or calling to print out the string. So you need some argument. You need some argument for the print function. And that argument need to be stored into a specific register, like argument 1 register, argument 0 register. Those are the standard argument register that you need to use before you call the system call. Okay, otherwise you cannot pass the parameter to the print function. Okay, so these are the basic system call one. So here are a few registers that you need to remember. So here, these registers are very important. Whenever you call this one print integer or print float, this standard register need to be used. You need to load the right address or data into this. For example, the address of string need to be loaded to A0 so that you can print that string out, okay? And that string, you better actually declare by ASCII Z so that you end with the \0, okay? Something like that. You have to declare something, the label in the right way. Is that okay, Eric? Remember that you have that string str that ASCII, and then you do the hello or something there, right? So you can declare a string with the address str. But the address str need to be loaded to A0 before you call system call number 4, right? Before you call system call number 4. And then you need to load a 4. You need to load an immediate data 4 to the function V0. A is for the address of the string. 0, V0 need to put the which function, service function vector you want to have. Okay, so that's something we need to know. So now we look at the example. This one is called adding two numbers. So this adding two number is we load the value from the value to T0. So here it actually is a pseudo instruction, right? So this load address, it actually will be translated to what? To add some value from certain register, right? And then actually with some data, right? And then it's saved to the register T0. You add that so that you can get that, okay? actually you would be at the I register 0 with the value of the value and then store to T0, right? So that's really a pseudo instruction you will run using this pseudo instruction. So after that, we had the load word with this. Okay, what is the memory address mode here? 0 and then ST0. This one is called a displacement address mode. So actually, you use the address pointer of T0 plus 0 to go to some memory location to get the data. Okay, and this one is called displacement address mode.
So is this one T0 plus 0?
T0 plus
the
T0's value plus 0's value as a pointer to get the data.
What?
T0's value plus A0's value, T0's value plus is this called displacement address mode. We call it a displacement register mode. So right here, the register now is what? Now the register is
T0.
T0. Address is 0. So you have T0 value as an operand, as a pointer plus that 0, it jump to the memory location and get the data. So T0 is like P, right? And this 0 is like index 0, right? Using that address to get a data from the operand.
Okay.
Is that okay?
Yeah. So it's like the index of an array.
Yeah, so it's called displacement address mode. That's why last week I spent some time with this one. Okay. So now that we have this, let's look at this program. So let me go to my directory. No, not in here, in QtSpim, chapter 2. Okay, so right here I have this one called what? Sum of 2, right? Here I open with a notepad. So here I store two value, word 10 and 20 and 0. So here, how many value I declare here? How many value I declare by this line?
3.
So this one actually, and what is each individual's size? Word is 32 bits. So usually this one is equivalent to unsigned integer, right? And then I have the word 3 equals 10, 20, 0. Is that okay? This whole thing is the same as the C language like this. Is that okay?
Mm-hmm.
Okay. Now the first one I load the address to T0, and this one, so actually is this one actually is like T1 equals my T0 is actually the value plus T0, right? So actually is the value of 0 assigned to T0, T1, right? And then the next one is plus 4 because that is actually a word size. So actually is the value of 1 assigned to T2.
Why isn't 1 not 4?
What?
Oh, it's because it's that.
Right, it's an unsigned integer now. Right?
Mm-hmm. So why is it 1 not 4?
Wait, this is C language. This is C language.
And?
C language we declare as integer.
Yeah.
Yeah?
So why is it not 4 and not why is it 1?
In C language, each one increment would be 4 bytes.
Oh, okay.
Right?
Okay.
So actually we just like we have like 10, 20, and the 0. We load this one 10 to T1, 20 to T2. Okay, and then we add T1 and T2 and store to T3, right? And then we actually store the value of T3 plus 8. So basically the last one actually is store T3's value back to my value 2. So actually the last one is like value of 2 equals T3. So we actually have the eventual result is like T1, I get it from value 0. T2, I get the value from value 1. And then T1 and T2 sum up together, save to value 2. Right? And then finish my program. So let's run this one. Let's run this one. Let's run this one. So right here, I have QtSpim, right? So here actually, let me actually, first thing I need to do is like reinitialize and load, right? And then I go to my chapter 2 and go to my sum2, load the sum2.s. Okay, after that, let's see. Okay, after that, let's see. Okay, the first one, load the 0, 29, something. So let's look at the data. You see here, it has the SP, the stack value, and the data value. So basically, right here, as you can see right here, you declare the different value 0. So here actually is this one's 10, this one's 20, because 1, 4 in base 16 is actually 20. 0A in base 16 actually is 10. Right? So we actually declare these two different value over there, right? And then actually we have that, and then we kind of, now let's run the first step. The first step is like, we do some system call 10. 10 is what? System call 10 is what? System call 10. System call 10 is exit. Let me see. System call 10 is exit. Okay. Wait. No up. So at this moment, my T1 is A, my T2 is 14, right? And then my result is called 1E. 1E is actually 10 plus 20 is 30. 30 equals 16 plus 14, right? So that's the result you store in T3. And then that's finish the call. So we can actually go back to reset the register, and that's actually reinitialize the simulator. Reinitialize the simulator, okay. And then we actually start to step on it. Okay, first we get the first instruction, second instruction. No, this is not the one we want to have. So let me actually reload the program from sum2. Okay, and then this time I don't run, I get step. So first one, I had a program counter of 4. I get an instruction this one, right? And then the second one I step. I run this one, I go to the next instruction, right? And then I continue. So here I already actually V0 10. I load the service routine 10 to my register V0, right? And then the next one, jump to main. So here you jump to main. So you go to jump to main. Main function, it will jump to main function. So now it passed here, it actually jumped to main function. So I use the values value with this number. So it will be load the values value to T0. So T0 now being loaded with this value. Right? What's that for? I don't know. The next one actually T1 you got an A. Right? And then the next one your T2 got a 14. Right? You add the two upright. So that one actually is the loading function. And then you sum up, store the value back to your value, and then you actually finish your program. And you go back to your main program before the main actually, and then you snore up, and then finish that and call system10 to exit the program. So this one it need to be added in order to make it run. So now there's a question: can we print the value out to my console? Because so far we are working on the register, but we did not print out the data to my console. My console actually is empty, right? So now let's look at how to add data, print data to console. So in this case, if we do the operation, but eventually we want to print out some data to the console. So here I actually can do this. Here I should have the message, right? And then here is like ASCII Z, right? And say 10 plus 20 equals, right? And then right here, what should I do? I need to print that message out, right? Because I store something in there and then I need to print something out. So in order to print something out, what I will do is like go back to my, this one to find some example to print out the hello world message type of instruction. So let's go back to the hello world program. So here, hello world program, you need to do this, right? Message done this and then \n. I don't need the \n, so this one's fine. Then I need to copy this over, right? Load my memory address to my, I need to load my MSG to my address 0, and then load my function 4 to my service function routine, right? So this one is load my message to my my register 0 and load my system call to there. After that, what should I do? After that, actually, I also need to do system call, and that will call system call for to print out, right? So the next one is right here. I just do some system call, and that will just call write out the messaging, right? And then the next one is like load immediate load. Now the next one is like I need to move, right? Move my value to, because right now I'm going to print out next one I'm going to print out an integer, right? So, and then the next one should be I move like, I need to look up my service routine for printing the integer. Let's go to my printing operation for a integer. So because I'm going to print my data in my integer, so I need to put my integer in A0, right? So my integer result right now is in T3, right? So basically I need to move my T3 to my A0, right? And after that, I need to load immediate data. This one with V0 with number 1, because this one is to print load the system call print integer, right? So this one load my argument to print integer, right? Right? So after I actually print out my message, this one, I print out my message here to there, from the registry to that, and then I do system call again. Okay, now let me save this one. Okay. And then right here, let me actually reinitialize and load my sum2. Wait, which one create trouble from T3 parser A value? There's some parser value. So let me don't write that long. Here, don't write that no documents. So how about this? How about don't use move, use load immediate data instead of move. Okay, and then the comment is okay or not okay? A0, T3, or here, let me do maybe there's no data after that. So let me do this T0 with A, because I'm going to get it from my location, the memory that it is stored by the store. So it could have been destroyed for the data. Let me actually do this. T0, load my argument. Something wrong. Where the error? Oh, here let me do load the word. Not load the ages, load the word. Okay, this time, and then that means wrong. Okay, see that? So you still need to have some trial in order to make it run. You know what I have done here? So the first two parts is do calculation. After here, do calculation, right? And then here I do print out the message, basically I print out this line, right? And then after that, I load my result from my memory, and then actually, I perform the system call one as a print integer.
So you can load two values to one address. Is that possible? Or wait, you loaded one to T1, and then you loaded another one to T2, and then T1 plus T2, and then
to T3, yeah.
And then you take.
So the data flow is like value of 0, we load it to T1, right? Value of
T3.
1, we load it to T2, and then T1 plus T2 to T3, T3 to value of 2, right? And that one actually I load this one to A0, right? And before that actually I load the message to A0 first and print out the message.
So down here, the LW A0 to load my argument. Why did you not use A0 comma $T3 instead?
Yeah, I think that one already gone. When you store, actually T3 is clear.
T3 is cleared?
Yeah, I think it's released. No longer has the right data. So this one actually is better. You have to store in some memory and then.
Oh wait, stores T3 to T0's second.
Yeah, you actually do this.
Oh.
That store SW do this.
Oh, okay.
And then I load it back by doing this. And I perform my service call 1. That's a print integer.
And then this load address value into T0, the first line.
Yeah.
What does that do?
Which one?
The first line of main.
That actually load the T0. So that actually first one I assign the address value. Yeah. So it's like value actually is a pointer, right? Value, this guy actually is like integer body value, something like that. Right?
Mm-hmm.
So this one actually loaded to T0. So T0 is a pointer.
So the T0 have values.
0 plus 0 use a value, so it's a body loaded to T1. So this is equivalent to values 0 data being loaded to T1.
Okay.
Is that okay?
Yeah.
So this I slightly modified it, but actually give you more idea, because if you don't show it in your console, it's hard to understand what's going on. If you just read the register, somewhat take more effort to understand, right? But it's not hard, just need some time to get used to it, okay? So the next thing you can do is actually, I'll assign you some homework for this, okay, to practice the addition, subtraction stuff. Okay, so we actually finished that first example file, example program, and then let's look at the second one. So second one is actually sum of 10 and 11. So basically, I just load the register immediately. So basically, ORI is a loading function as well. You will figure out that. So basically, I load a immediate data 10, right? So it actually is adding the immediate data with 0 to 8. So that actually is, this one I think is also adding. So I think it's adding a register with immediate data. Okay, so here actually load A and then load 11 to 9, and then I add A and 9 to 10, okay? To register 10, register 9, register 10, okay? So here, let's do this, okay? Let's do this. So let's actually open, I'm sorry, not here. Actually, this one, let me close. Okay, now let me save all. Let me open. So now sum 2 is finished. Sum of 10 and 11 got code. Okay, so it's actually right here, we do this, and this, right? So the next one will be, if we want to add something, okay, try it here. Okay, if I want to put something, I still need to declare some data region, right?
So this is not the pseudo instruction, it's the other one?
This one is pseudo instruction.
Then what is ORI?
ORI, yeah, ORI is not pseudo instruction, it's actually a real instruction. Okay, so we want to declare some messages. So here you need to do MSG, right? What should I do next?
Colon?
Yeah, colon, and then
ASCII Z.
And then
you write
here is
10 plus 11 equals
10 plus 11 equals, okay.
And then
go down to here, right? And then what's next? You have that message, right? So you need to load the address. Load the word, right? And your address that will be stored in A0, right? The parameter. And then MSG, right?
Mm-hmm. And then you have to print it out.
So that okay, the next one should load the what? Immediate data.
Into the system call.
To the call number V0 with this one's message before, right? And then do system call. Is that okay? That's up to here, okay?
So why is that 4?
It's service routine 4. That's the service routine 4. Remember this call number? Print string is service routine call.
Oh, okay.
Print 1, the integer is print service routine 1.
Okay.
It's like print F with something, So here that's a save.
Uh-huh.
And print up this guy, right? And right here, that's actually we initialize a low. Here, let's load this one, 10, 11. Okay, so this time actually, okay, it has something wrong. MSG, ASCII, let me see, passing error. Okay, the passing error, what is that? Let me compare with my one in sum 2, right? Let me actually also open sum 2. Compare, okay? Because right now we are still learning, so let's compare. What is the difference? MSG, ASCII, and then sum 10, 11, MSG, ASCII. What is the difference? So how about I delete this one to this one? Okay, how about I delete this one? Maybe that one actually create trouble. It's a low W. Let me see if the one is low W or low edges. Let me actually open. I think it's low edges. Let me see. It's a low. Yeah, it's a low edges. Okay, because it's a pointer, so you need to low edges instead of low W. Low W will be loading the value.
Go back.
Yeah, this one is actually low the edges of the message because it's a string, so you need to load edges to there. So you'll be indirectly go to there. So here, this one is low edges, not low words, not low integer into there. Is that okay? And then let's say, and then you go to your here, then we initialize a low file. Hey, what's wrong? MSG, what's wrong with MSG? I have a data, no MSG, what's wrong? I have a data, MSG. Oh, there's a dot, I'm sorry. So here the ASCII, it's a directive. You need to put a dot in there. Is that okay? It's called directive. So you need to, that word, that's something, okay? That's dot ASCII, okay? That's like data type declaration. You need that dot. Okay, so now let's load. Okay, this time is okay and run. Okay, see where is the screen. I may have closed the screen. So here, let me cancel. Okay, okay. So I haven't printed out the data, right? I haven't printed out the data. Now the data is where? Now my data actually is in my program, right? My data actually is in register 10. So what I should do is actually now, let me try. It is possible to, the next one is, I need to print the integer out, right? So I need to actually put my integer into my A0, right? So here, let me try, if it is possible, I load the A0 with my, I can do this, add immediate A0 from my 10 and 0x0. Is that okay? Right? So I'll have data over there, and the next one actually I say load my service routine v0 is number 1 and do system call. Is that okay? Because this one I want to prepare. Okay? Let me try. May work, may not work. I don't know. Okay, and that's wrong. You see that? So here you can use move or you just add and the 10 register 10 the content with the 0 and then so this one might probably work better than move, right? Okay. Or if I try, I don't use the immediate data, what can I do with that? I can also use the registered 0 because it's always 0 over there, right? I don't need to actually use the immediate data. Immediate data is like you give a 0 data, right? This one still work. Okay, so probably this one's better. Okay, so that's actually add into number and print now. Okay, and this one, let's see, the next one, program 1, program 2, program 3, swapping the memory allocation. So I have a data 3, word 3 and 7, right? I have a 3 and 7. Let me see here. I have a 3 and 7, and then I load my the address to upper word of the immediate data to my S0, and then actually I actually load them to S1, S2, and then S1, S2 store back S0 and S1. That actually will swap the data. What it is like I put my address to here S0, and then I use my S0's address plus 0. I load the data to S1, right? And then I load my data S0's 1 data to S2. And then my S2 store back to this one, S1 store to this one. So then I complete the swap function. Is that okay?
Uh-huh.
Okay, so that's actually the assembly swap function. Okay, let's try this one called swap to memory words. So here, let's load and initialize swap to functions. Okay, and then that's actually run. And what did I do? Actually, the memory is 3.7 now. Original should be 7.3. Original is 7.3. Now it's 3.7 now. Is that okay?
Mm-hmm.
So that's the swap function. So the trick is like you load the data starting from 1010. 1010. That's the upper immediate data for ages. So that actually is something need to be remembered. I don't know. He just happened to know the data will be stored over there. He just know the data will be stored there. I don't know what's going on. Okay, but I think it's better to put some label here. Okay, and then use the one we use in here. Load the value to S0, and that value has the ages, right? This is actually safer than that one. Is that okay?
Mm-hmm.
So let's try. Let me try another one. Okay, instead of overriding it, let me actually in my program here. Let me see. Let me load that one in swap to memory. This program that is. Let me save us. Save us right here. Let me actually swap whatever word number 2. Okay, instead of doing that, let's do this. Let's actually, this one, let's put into set line. And here, let's also, again, do it as a value. Okay. And this one, because I'm modifying to the memory swap load 2, so that's not a problem. So here, actually, I do load ages $sign S0 from my value, right? Suppose these two should be the same, right? And then my QtSpim, we initialize like I need to lowest one. Right here, I need to save. Yeah, save. And then right here, my machine, I have two. So to open. No, there's nothing like that. Let me actually quit the environment. Quit the whole thing. Okay. Let me actually save us. Maybe I set to the wrong. Oh, I save it as a R file. I didn't save it as a S file. So here I need to save this one as .s. Okay. That's my one mistake I make. I didn't know that you won't add the right extension. So right here, let me load again. Okay, this time I have the number 2. Go back to my text file, so it's right here. Okay, and then let's look at data. Okay, it still works, right? Now what I need to do is I have the 2 ages in value, right? S0. So I set to back to that. So what I'll do is like print out message, right? So here, what I should do is like message 1 dot ASCII Z right, and the message 2 dot ASCII right, and here I should load address. A0 is message 1, right? And then the next one is I should do load immediately value V0 with service 4 system call, right? And the next one is I should load address, and then here A0, and then I should have 0, and then star. No, I should actually, now I should be loading word because I want to get the value over there. So I need to load my value of 0 as $sign S0 to A, and then actually load the service routine 0 with service code 1 and system code. Okay, so this one actually will print out the first one. Originally 7, now it should be 3. Okay, after swap it should be 3. So here I save, and then right here I load the data into my program. Program into there, run. Okay, variable 1 is 3 now. Okay, and that is successful. So what I need to do is like copy this whole thing again, right? And pass here, right? And here I change to 4. Is that okay? Is that okay, Eric?
Yeah.
Okay, now actually I will load the value from here, and then I run. Oh no, I'm sorry. I'm really sorry. I just print out the data. So what I need to do is actually, here I need to do load my message to 1 over here, right? And then here I should put this. Okay. And then it may not change line. So what I need to do is here I should do something called endo. Right? Other name probably not easy to remember. But this one, I'm sure everybody will remember that. So this one, let me actually print out this. So I copy this whole thing again. Pass over here. right? You know what I'm doing right now? Do you know what I'm doing right now?
Yeah. You're printing the second message out.
Yeah, and also actually I printing the change line mark out. So this one is equal to, is that okay? This is 3 line. This 3 line actually equal to this. Is that okay? Is that okay for these 3? And this 3
Yeah.
line equals the C out. Is that okay? So with this mark, I try to put this mark there, so when you do programming, it would be easier for you to remember what you are doing. Okay? So let's try message 2, here 4, here 0. Save all. Right here, and let me actually load. And that's wrong. You see that? You see that?
Mm-hmm.
Okay, so here it give you some trick. Some part that you already know what's going on. This one, the whole thing is just like this. Okay, this whole thing is just like this. This whole thing is just like this. So it's somewhat like you are writing C double plus, right? So this whole section right here is more or less like right? This whole thing right here is more or less like this. Because it's an integer, so you need to use the service routine 1, right?
Mm-hmm.
It's somewhat like this. And then with that, actually, you know that, okay, what I'm doing is this. So here is a series of the CL operation. And then here, it's actually, this one's more or less like loading the data to the CPU. And do so basically you go into a definition of data, loading the data from the CPU, from memory to CPU, and then CL stage. Okay, and at the end you jump back to your program. Is that okay?
Mm-hmm.
Now that will be the return and finish. Okay, so that's another one. Let's try. There are 2 more programs. Let's try the next one. The next one is procedure to swap 2 array words. So the previous one actually is only swapping 1 array words. Now we try to swap 2 array words. So both of them actually are now an array. So you try to swap array A and B together, from one memory location to one array to the other. So let me see. This one should be program name is what? And make sure I have the right program name. Call procedure call programs. Okay. So there's some procedure call programs right here. So basically, I load an array to this one, and then I actually load my S00. So I initialize my A1 to be 0. So I actually copy 0 to my A1. A0 is an array, and then there's a step pointer -4. So step pointer becomes step pointer -4. And then actually I use my step pointer's address and then store my RA's return address to my step pointer. Okay, RA is my return address to my step pointer.
Wait, Addy
Add
does
immediate data.
it adds the thing in 0 plus 0
So
to A1?
A1 now is clear to 0. A1 is clear to 0.
Cleared? Then what is this $0 thing?
$0 is register 0, and register 0 store always with 0. You still remember that one?
Stores AO with 0?
Store, no, $0 is 0.
0?
Yeah, $0
Okay.
0 is 0. So remember your register, your number R0 register 0 is constant 0. It always is constant 0. You cannot store anything in register 0.
Mm-hmm.
Is okay? For MIPS, it's like that. So you actually cannot store something in there. So actually right here,
So it's 0 plus 0.
the first one is
Put in A1.
the address of array being loaded to A0. And then A1, you load this one.
Load both of them?
No, these two sum together is 0. So
Okay.
just copy a 0 to here. Now this one is like AD is the, you use that to -4. So basically what it is like, I have a memory address, right? My stack pointer is right now pointing to here, but my stack pointer -4, because a address is 4 bytes. So I store here with my return address. Because of what? Every time my stack pointer continue to actually grow. So my local variable will be put in here, right? But my return address is actually in SP -4. So I need to store my return address to there. Is that okay? That actually the whole thing is just to store the return address to there. And then after that, I jump to swap. So basically it's like, this whole thing is like, it just do one thing. It just actually do one thing. This whole thing is just do one thing. This is actually a function call. This whole thing is just like A0 equals address, I'm sorry, the array address, right? After that, actually it's calling swap. Something like that. Is that okay?
Yeah.
So you go to the swap. So go to swap. After going into swap, you don't need to care about it. You actually go into, so this one actually is different from previous function. Previous function, we are not calling any function call at all. So now you go to jump address, okay? You jump to the address for that. And then you go to the swap. So swap is right here, right? After swap, actually it has the last one is the return address. So you will go back, get the return address, go back to the program. So you run here to here, then you will finish. And after you finish, the program will go back to the line below this jumping swap. So it will be going to here. You know what I'm saying? So what is like this? This actually is a function called swap. So you go to swap, finish, right? Come back to the line, the next one. Right? And then I use my SP stack pointers location, get my the return address, right? And then I F4 back. So my return address get it, and then I actually restore my stack. So basically, I go back to my stack. You know what I'm saying? I restore my stack pointer, and then I finish. So basically, this one is this whole thing over here is the pre-processing for function call. This one is the after processing for function call. Not including the last one. Not including the last one. The last one is the finish the function call. So basically you have two regions. These two regions you need to be careful is that whenever you want to write a function call, this is the preparation for function call. These two actually are the finish. After you finish call, restore your return address and restore your stack pointer. Okay, and inside here the swap function is just like doing this. So let's do the swap function first. So basically you add your A1 to T1, okay? So basically your T1, first one is T1 equals 2A1, right? 2A1's data. And then add T1 to T1. So actually add T1 to T1. So T1 is actually 4A1 for a second. And then add T1 A0. A0 is what? A0 is actually, I'm sorry. A1 is actually, A1 originally is what? A1 originally is 0. So A1 is 0. So T1 is 0. T1, 0. T1 is still 0. And then A1 plus 0. So original T1 is A1. A0.
Still
so
0.
A0 data, you store that
0.
0. And then the next location you store
0.
you actually load to T0. So basically you use the, so T1 is actually A1, is A0. T1 is actually, T1 is the address of A0, and A0 is array, right? So T1 is the address of array. So array 0 assigned to T0, right? And then array 1 assigned to T2, right? And then you swap the data. And then you swap the data, right? By the store. So it actually is a swap function, but also swap two data, right? And then what's going on is that you actually swap two data, and then what's that? It actually, here you actually swap K and K plus 1. Okay, so it's actually swap K and K plus 1. So here actually you jump to a swap, jump back to the return address, and so what? It actually, let's try run this one and see what happened to the result. Okay, so basically let's load my call procedure 2, and let's run. We don't know what it is, but if you look at data, what it actually do is only swap into 2 elements in the array, the first 2. Is that okay? 3, 2, and 1 are not affected. But it actually is to swap, to using the function call to swap 2 elements in an array, right? So what it is, it's actually the swap function is just like this. It call this, and then okay. Where is the K low? Where's the K low? I think this one's K. The 0 is actually the K. Okay, so here, for example, if I put like 4, 4, 1, 1. Okay, so swap contain element A1 with A1 plus 1 of the array, right? So A1 value actually will be, A1's value will be the K. So A1 is the K. So here, right here, if we don't do 0, let's do 1. See if we will swap 3 and 4. Okay, see if it will swap 3 and 4. You see, it swaps 3 and 4, right? So this one actually, okay? Let's see. Let's try again. Okay, so that's true. So right here, actually, let's put it back to 0. Okay. So here in this lesson, we learned a couple of things. Number one is how to deal with the array. Okay. Number two.
Well, I don't get why you add so much stuff in swap.
You don't get why you get so many things in swap.
Why do you add so much things in swap?
Let me see. Why you add so many things in swap? Oh, you actually want to calculate the right address. You want to calculate the right address. So the last one actually, basically, I want my T1. Initially, I want my T1 to be the A0 of my K, right? Array K, right? Right? I want my T1. Eventually, I want my T1 to be that value, right? So then here, T1 should be the calculation for K. So this is the last one should be K, right? So if I put a 1, right? If I put a 1, I should actually end up with my original A0 and plus address of 4 and get a body instead of 1. So this one I think is double. 1. So T1 now is become, if A1 is 1, it will become 2A1 to T1. And then 2A1 plus this become 4A1. So if A1 is 1, T1 will be 4. If A1 is actually 2, T1 will be A. So basically T1 here, the last T1 you use here will be, here it's just trying to create 4A1. Is that okay? Here you sum up together. So here actually should be, for this one actually should be, you try to create multiply by 4, but it doesn't have the multiply function. Right? So right here again, this one is like, something like that. Is that okay? Something like that. And the right here, this one actually is to prepare the function call. Actually is stores state pointer -4 to SP. Also step pointer -4's address to the return address. Okay, that's the you program counter currently, and then jump to there. After that, you use the step pointer -4 locations of data, and then restore to your register return address, and then actually after that you restore your step pointer, and then you do jump to the return address, finish the program. So here, actually here. This one is store return address to step pointer -4. Okay. And here this one's call swap. Right here, restore. Here, right? These are the function. Okay. So here are the function. So here actually we have a function call. First function call in MIPS. Okay. Next time we see some function call, we will actually code it. Now the next one. Now the next one actually is right here. The next one is to procedure call swap. We finished that. The next one is sum of two integers, but using a function call. Okay, using the function, using the system call. So let's look at the program again using our Notepad double plus. So let's open the fifth program. I think this one is easier than previous function call one. It's for system call. So system calls S, okay. So you enter two integer from console window and then display, okay. So the first one is low ages of value to T0, right? Call system call number 5. So what's the system call number 5? System call number 5 is to read a data. So system call number 5 is read integer and the value will be stored to V0. Okay, so the value will be stored in V0. And then the value will be V0. So here actually it will finish. So this whole four line actually will complete what? This is the whole effect of this four line will be quite simple. This four line will be this four line actually only do this. Is that okay?
Mm-hmm.
So this four line actually finish this, right? And then we actually read again and store in here. So actually this one is right, store something in there. And then actually this one will load the value of 0. This one's a low, the value of 1, right? And then here actually this one is T3 equals value of 0 plus value of 1. So here we have a scan in now. We had the input, right? And then this one actually eventually will be values, second value will be actually the value of 0 plus value of 1, right? And then we call the V4 with message. Message is what? Message is sum equals. Okay, so here actually right here will be right. This part is C out like this. After here, and then number 1 is print out the number, right? Number 1 is for print out the number, so integer. So here is like C out T3. So here would be like the value of 2 in print now for this part. Okay, I zigzag in the sharp sign, so you probably know it. And then the last one is like call the service routine 10. Service routine 10 actually is the exit with 0. Finish the program. Is that okay?
Mm-hmm.
So that whole program is just like this. I think it's not difficult. But here is like this one comes with input. So today we learned about how to scan in some data like system.in the scanner. You can get a scanner to do something in using cin. And you will also learn cout.
Mm-hmm.
right? And you also learn function code, right? That's today we learn all of these.
Yes.
And then the next thing is that I need to assign you some homework to do
Practice.
some program, yeah, some not so difficult program,
Okay.
and not involving any difficult multiplication, just subtraction and addition,
Okay.
right? Multiplication can only limit you to multiple of 2 or something you can handle with the simple arithmetic. Okay, so here we have a text. Let's try. Oh, it's reading for some data. So here, let's see. Here I have a 3, and then it will read in for another one, 7. And let's see, here it will get 7, and 3 plus 7 will be 10. Is that okay?
Mm-hmm.
So here I can improve the program by what? I can improve the program if I actually come here, right? Right here, I can have the message to that ASCII. Something like this, right? And then before I actually load some value right here, let me do this. Load HS, just like A0, and this G2, right? And then load immediate data, load the V04. If you actually write this often, it is not really that hard, right? And after I get some data, let me see here, let me actually copy the same thing for when I try to read another data. After I do this, it will do the same thing. Let me actually read out this one, right? Let me actually do this. Let me save all. And in my program, let me actually try. You don't need to do that, whatever I'm doing, but I think that will make our program more readable. So here, like 7, 3, right?
Mm-hmm.
Is that okay? Is that okay so far?
Yeah.
Okay, that's it for today, and then I'm going to assign you some homework. Okay, bye now.